Hello, everyone. My name is Kristen Vanderwall, and I am the Product and Marketing Manager for Hendrix Overhead Solutions. I will be your host for today's webinar titled Spacer Cable Installation. This is the third webinar in our four-part series we're conducting between now and the end of June. A properly designed and installed Hendrix Spacer Cable System will provide a lifetime of low maintenance and highly reliable service. Despite its unique configuration, it can be installed using many of the same techniques already familiar to distribution line workers. We will detail the specifics of proven installation techniques for Hendrix Spacer Cable Systems, including our typical roll-by and pull-by-pull methods. As for today's format, we will begin with a 45-minute PowerPoint presentation, and we'll follow that with another 45 minutes of Q&A for a total of 90 minutes. Many of you are already familiar with the Q&A tab located at the bottom of your screen. During the presentation, please use this tab to submit your questions. I will be screening the questions as they come in and will relay some of them to our presenter during the presentation. Then, as time allows, we will address all other questions during the Q&A segment. Anyone who submits a question that we do not have a chance to get to will receive a response in writing from us. Now, I'd like to introduce you to today's presenter, Mr. Carl Douglas. Carl Douglas is an engineering field representative at Marmon Utilities and is located in Rochester, New Hampshire. He holds an AAS in Electrical Power Technologies from Bismarck College in North Dakota. Carl has worked in the utility space for over 38 years. A certified 35 kV rubber glover, he was a line worker for over 15 years and built and managed spacer cable installations in several roles from project manager to manager of operations. His role at Marmon is to work closely with clients and contractors to ensure the safe and efficient installation of spacer cable across the United States as well as abroad. Now, I'd like to turn things over to you, Carl.
Thank you so much, Kristen, and thank you so much for participating today in today's webinar. We're going to go over spacer cable installation. Many of you, I'm sure, have a concept of what spacer cable is. However, we're going to try to dispel some of the angst that is associated with the installation of spacer cable. It is not difficult to install, however, it is different than many line workers and line crews are accustomed to or exposed to. And we're going to take it for the next 45 minutes and hopefully leave plenty of room for your questions, and we can give you good solid answers and give you a good feeling as to the application of spacer cable on your systems. On the very first slide, as I stated, it's not difficult to install spacer cable. However, it is different than open wire configurations. On this first slide, I included a link to our online catalog at Hendrix so that you can, at your leisure, go in and look at all of the parts and pieces that are associated with a spacer cable system. Everything from the conductors themselves to different types of wires, the different type of angle brackets that are associated with spacer cable installs. These are all hyperlinked. So at your leisure, please go onto our website, take a look around. As we all know in our industry, every single job has its own unique hurdles to overcome. And by understanding the parts and pieces that go into a spacer cable system might give you a better understanding of how to get around some of those hurdles. So with that, we are going to certainly start with safety, which is paramount in our industry. We want to ensure that anytime you're working to install or maintain spacer cable, you utilize insulate and isolate principles, exercise minimum approach distances, certainly utilize switching and tagging protocols for your individual company, defeating, reclosing when working or installing any type of conductor is critical to the safety of not only the line workers working the system, but also the system itself. We certainly encourage a pre-job briefing by all those that are going to be affected or in any evolution of a job, to ensure that all safety barriers are in place and all issues are briefed with all of the folks that are on the crew. Spacer cable is different than bare wire, but it must be treated the same. That is a pretty critical piece. Even though our spacer cable is covered, it still has to be treated as if it were bare. And I will point you toward references OSHA 1910.269 to give you guidance on issues relating to our industry and spacer cable installations. Certainly, when you're installing a spacer cable system, you're likely going to be either replacing or adding this to an existing pole or circuit. Anytime that there are potentials that are available at any location, we want to make sure that we cover with covering that is rated for the voltage that you're working on. Anything that's going to come in close proximity, or even if something were to go wrong, to ensure the safety of all of the workers on the job, as well as the safety of the public and the system itself. We want to make sure that you use rated cover to cover potentials that may be impacted during a work evolution while installing spacer cable. NESC 230D requires spacer cable to be treated as bare conductor for the purposes of working clearances and maintenance. If working a system live, insulate and isolate methods must be used if rubber gloving, and certainly minimum approach distances for sticking jobs for those that are unable to actually handle the conductor. Well, we're going to talk about a couple of different methods for installing our product today. Interestingly, when a job is completed, it is virtually impossible to recognize or ascertain the installation method that was used. The design usually will be designed for the end product, and how the product gets there is what we're going to talk about today. We're going to talk about two different methods, the roll-by method and the pole-by-pole method. Spend a lot of time on the roll-by method because that is a tried and proven means of installing spacer cable. However, the pole-by-pole method might give you a little bit more latitude in terms of actually installing spacer cable systems. Roll-by method is definitely an efficient means of installation. It is executed by rolling blocks that run out on the line and will eventually be replaced by spacers, hence the name spacer cable. It's fantastic for straight runs, for runs that might not have many elevation changes, and runs that stay on one side of the road. However, it can be used even though there may be corners that are present in the line. However, you would have to start and stop the installation of the running blocks, which we'll cover in detail as we go. The pole-by-pole method is something that is really, really great for, again, elevation changes or hard corners that are present throughout the job that you're working. They essentially use a 3-shift block at each location on the messenger where a spacer will eventually be placed, and it uses a different type of leading sled that actually pulls the conductors in through the 3-sheaf blocks along the line. Still uses 2 pulls, and essentially that's what we profess here, is that for open wire conductors, as many of you know, there's 4 different conductors that have to be pulled, the 3 energized conductors as well as the neutral. When installing spacer cable, it's basically 2 pulls, and you'll be still pulling in three different conductors, but one will be a messenger, and then the 3 energized conductors, or that will be energized, will be pulled all at one time. Very important note at the very bottom of this slide: a pre-designed walk down with both construction and design resources of the circuit is critical to determine the installation method that is going to be used, whether it be roll by pole, or some hybrid method that we may not cover today. Tool and equipment placement, temporary guying, as well as any other installation issues can be engineered out of the construction process in the design phase. That's a very critical piece for the 2 entities to come together to ensure that the installation is safe and is consistent. So as I said, the spacer cable parts and pieces are remarkably different than that of open wire. Open wire uses cross arms, spread out phases with energized conductors on top, with the neutral running on the bottom. Spacer cable is significantly different in its design, its compact nature. You're looking at 2 basically hanging arms that will support the system at the pole. BM14 is a 14-inch arm that attaches directly to the pole, will hold the weight of the messenger at the very end, as well as the conductors in a diamond shape. The BM24 is nothing more than a 24-inch arm, and you see the eye at the very bottom of the BM24. This is to hold a running block for the messenger in particular. As you can see, the 14-inch and the 24-inch are voltage specific. So these are what our entire system in a tangent, in the tangent space, is going to be supported at the pole location. As you are probably well aware, porcelain has been a great insulator in our industry for many years. However, we have shifted to polymer, certainly more resilient, has a better track record. You'll see right here, there are 2 separate insulators that we provide. One is a tie top, one is a vise top. Tie top can be used to tie the conductors in with using poly covered tie wire to go over the covered conductor. The vise top is certainly a lot easier, hot stick accessible. You can see the eyes on the right hand side of this picture. These are shear pins where you release the pin, put the conductor into this groove, and then tighten down these pins until the eyes actually break off. When they break off, that gives the proper torque to hold the conductor in place. And then you're left with a nut here that can be driven out while maintaining the spacer cable. Again, some of the parts and pieces. This is a tube that actually attaches to the top of the B&M bracket, or the BM bracket, that can easily hold a P line and then pull the messenger back in through that. The lead trolley, you're going to see that this is a trolley system for the roll by method. This actually will run on the installed messenger and will pull the 3 conductors off this contraption at the very bottom. Slack bracket, a really ingenious advancement to pulling our conductors. As you can see, this is an open sheave where you can attach this to the pole. We'll have some pictures on this a little bit later in the presentation to pull your P line in, and then as you pull the conductors in, the P line will lift out of this. Again, the open end of the slack bracket will just lift that P line up and then and clear itself from it, but at least it gets the P line up in a position when installing the conductors themselves. And the PBR stringing block, you'll hear me refer to this throughout the presentation as just a PBR. This is going to attach to your lead trolley. It's going to house the 3 conductors on these 3 shivs below, and this will actually ride on the installed messenger as the conductors are pulled in. Again, some advances, as you'll see, for angles. We have the angle stringing block that actually attaches right directly to brackets on the pole. These can be leaned at specific angles to accommodate corners. And then the PAT1 angle tensioning block is a block that is used to run the messenger typically. And then again, a new development that is relatively new to the process of installing spacer cable is the PSAC, which is a permanent stringing angle clamp, very similar to the PAT1. However, it has this arm that once the wire, the messenger is in and sagged, rather than having to remove this block and replace it with some sort of bracket, this arm swings up and actually attaches to the messenger, and this block actually stays in place. The wire can't move because of this bracket, but it is a tremendous time saver and a great safety consideration for line workers having to reinstall. And for those that have never seen a messenger bucket or a bosun's chair or anything of the like, not all spans are accessible post installation. So the way that you have to access the rolling blocks and remove them and replace them with spacers is by actually rolling a person in this basket. You see this, the rollers will ride along the messenger. It actually has a brake. This is pulled along from the ground by ground personnel, and a person will stand in the basket and roll down the line and replace the PBRs with spacers as they go. So other installation equipment, many of these are going to be familiar with anyone that has ever run open wire. A three-reel trailer is probably a nice to have, but it can be actually done with 3 individual trailers placed in line, 3 arbor stands or something along those lines. But a 3 arbor trailer really is a tremendous way to house the reels as the conductors are being run in. And then a pulling rope, 5/8 or 3/4, depending upon the type of pull that you're doing. 3 shiv block. We'll talk a lot about 3 shiv blocks and single shiv blocks as we go. Wire mesh pulling grips, which may be referred to as pulling socks, are certainly important, critical to the installation of not only the messenger, but also the conductors themselves. Splicing sleeves, we'll talk a little bit about that. ACSR cutting bolts. You got to understand our messenger is very similar to a guy wire. As a matter of fact, it's almost exactly a guy wire, certainly in larger diameters, but bolt cutters are probably not going to have too much success cutting our messenger. So having some means of cutting, possibly a chain type cutter, is going to be important to cutting the messenger in particular. And then parallel jaw grips, a little bit larger because of the covering on the conductors, used for sagging both the messenger and the conductors. So we'll transition now into framing. Although the arms, as I talked about, the different pole attachments are different than open wire, they still use all of the same bolts and washers and square washers and spring washers and curved washers, if that's what your local standards call for. One thing that is important, again, in the design are guy leads, the tension that is created with our messenger, and it has to be very, very tight, probably tighter than any wire that many line workers will ever sag, is at essentially the top of the pole. So even the smallest corner could make that pole come over with relative ease. So it's important to try and maximize guy leads as much as possible in the design to ensure a stable system once installed. Certainly, the use of a spider system, if you're familiar with that, is very good for running a smaller line out to grab your larger pulling line from your puller tensioner back to the three-reel trailer. Again, the three-reel trailer or puller tensioner is very important when pulling in and around energized circuits, if there are circuits that already exist. The good news with spacer cable is the real estate, if you will, on a pole takes up very little space compared to open wire. So when you're rigging and out-rigging energized phasers to get them out of the way to accommodate the installation of the spacer cable, it takes far less movement of energized conductors to accommodate space for spacer cables. And certainly you want to bisect angles very similar to open wire. So essentially you're looking at a tangent pole that is framed right here. You can see this is on a 14-inch bracket. You've got the tube that is holding the P line that will eventually take the messenger through, and you'll be able to sag that and get that once you get that installed. Right here is that open slack bracket that I referred to earlier. Slack bracket just basically hangs off the arm here, and this is going to be what is used to pull your P line in, and once the conductors run out and trolley up near the messenger, this P line, this slack bracket, will just simply lift and actually go right up into place, and this will be out of your way and not cause any obstruction at all. For corners, corners can be a little bit tricky. Installation of spacer cable is not perfect, and every job is going to have, again, its unique set of circumstances, and the corners that are associated on any line are going to certainly give the line crews the ability to pause and work through any issues that are associated with the corner. As you can see that here, the P line goes through this single shiv block at the top. This is going to accommodate your messenger. Again, using that P-sack block where it would be a permanent installation is far better. A couple of slides from now, I'll be able to explain that better. And then a single P line for the conductors. Eventually, you're going to work the conductors through these and place all 3 conductors into these single shivs once the conductors clear that corner. Here is a real world, a real life example of exactly what I just talked about. You can see this is the PAT1. Strongly encourage the use of the PSAC so that this will never have to be utilized. And as you can see here, this is the permanent of what used to be the permanent installation of the messenger using an angle clamp. The ability to do that. Let me go forward just a little bit. As you can imagine, is a little bit problematic for the line worker. As you can see here, having to chain hoist to the back of the pole to put enough slack in this wire so that this block can be removed and that angle clamp can be installed with the PSAC. You simply leave the wire in the block, clamp it down, and move on to the next pole. So I'm going back to where we began. As you can see, you want to definitely use a swivel. Again, the messenger is a guy wire. It has a memory. It will twist and turn, and without the use of a swivel, will cause an awful lot of stress on your pulling rope, as that energy has to be transferred to something. So with the swivel, certainly makes that much easier. You can see here, pulling rope. The grip or pulling sock is on the messenger, and this is how you pull the messenger in. Again, swivel and a pulling sock and or basket, depending upon what your verbiage is. Standard puller tensioner is highly encouraged, especially when running wire on a pole where energized circuits already exist. And you want to pull the messenger in certainly under tension. When you pull the messenger in, you want to pull that in grounded. So the use of a running ground, this is again a steel conductor, and this is the one conductor in the system that is not covered. So you can actually use a running ground when installing the messenger itself by using the puller tensioner. The sag of the messenger is extremely critical. This is what the entire support system is predicated on in a spacer cable system. It's going to hold virtually all of the weight of the conductors once the conductors are installed. So we want to make sure that the sag is correct and the poundage is correct. So we strongly encourage the use of the dynamometer when sagging the messenger. Probably a 3 to 5 ton hoist is going to be necessary to get up to the 2,000 to 3,000 pound level that we suggest for our messenger installation. Always, line workers will want to take an extra click once they reach the desired poundage, due to the fact that you're going to lose a little bit from, as you can see, this basket that's hanging off the bucket here is what is the basket that is actually going to be holding the strain of this messenger at the dead end. And to wrap this dead end onto the messenger is going to take a little bit of space. So you're going to lose a little bit. So we encourage just a click or two extra beyond the recommended sag chart to ensure that you have enough room so that when you do let that off, you don't lose too much of your poundage. You can see with this chart that is included with all of our designs and with all of our bill of materials is the temperature, the Fahrenheit temperature the day that the wire is installed, as well as the type of wire and the expected tension that we want on the messenger for a given circuit. So in the higher the temperature, the more that is going to change. The colder the temperature, the more that is going to change. But that's very important for the installers to understand how the messenger must be sagged and the tensions that must be created when you are sagging. So once the messenger is sagged, you certainly want to remove the dynamometer, and you want to place the messenger into a preformed dead end grip at the dead end pole. Once that is installed, now it's important that you go to each pole location and secure the messenger at each of these arms. So as you can see right here, this is a picture of the end of one of the supporting arms. Simply back this nut off, place the messenger in this groove, tighten it down, and you're good to go. And you can see here, a line worker is doing exactly that. And then again, certainly an angle clamp such as this on a corner is acceptable. However, again, having to take the enough wind out of that run on the backside of that pole is going to take a pretty beefy hoist, and also taking that block out and replacing it with a angle clamp is a bit of a time waster. This is why we have developed this PSAC, which I have kind of detailed up till now. Again, use of a 3-rail trailer is critical. Now that the messenger is up in place, we're going to start thinking about where we're going to place the conductors. They have to be on one end of the job. The opposite end of the job will be the pull tensioner. And all of these 3 reels will have to be in line. We try to avoid having to splice the conductor mid-pull. Rather, in the design phase, we'd like to know what the length of the run is so that we can cut our lengths on the reel to accommodate the entire length of the run so that we don't have to splice. You can certainly splice spacer cable. It's a non-tension splice. We'll get into that in a little bit, but this is exactly why 3-phase or a 3-arbor trailer such as this is critical. For installing the conductors, you can't break the conductor. You want to freewheel these, take it in at a pace where you won't get the reels moving faster than the pull itself. You can, with a 3-arbor trailer, you can break the reel, but we don't break the wire. How we ground the wire as it comes in is by using arbor grounds that actually spin along with the wire, and you just take the tail out and either use driven grounds or whatever your local rules ask for. So this is a picture of where we are right now. We've got our messenger in place. It's sagged to the correct poundage. And now you've got your 3-arbor trailer with your 3 conductors coming up to the line, and we're getting ready to trolley these conductors out onto the installation. Right here, you see an example of what I'm talking about, this being the P-line. You still want to use a swivel, certainly. And this is the trolley sled that is going to be attached to all 3 of those reels and pull in together. And this sheave right here will run along the messenger and actually run past a tangent bracket without any issue. When you get to a corner, it gets a little bit dicey, but we can talk about that as we go. This is a picture of the lead trolley, really nothing to it other than an opening with a single shiv. This is where the lead trolley is going to run on the installed messenger. This is where the pulling rope and the conductors will be attached. And this is an example of what we're talking about. You can see a line right here. We're going to talk about this a little bit. You need to install a 30-foot line in between the PBR blocks. So this is the lead trolley. You can see the pulling rope here, the 3 conductors attached to it. This is going to be the first the first block that goes out onto the messenger as you're running in the line. And then every 30 feet, you're going to install PBR blocks, which we'll get to. What we like to do is right here at the takeoff pole, you can see the wires coming up from the trailer up to the pole. We like to train the wire, if you will. And in this example, there's 3 single shiv blocks that are training the wire onto the line. That's so that there's no excess sag and affect the trolleys and the PBR blocks as they're going onto the line, and it assists the line workers in installing PBR blocks as the line is running out. A better opportunity is right here, is to use 3 rather than the 3 single shiv blocks, a 3 shiv block where all 3 wires come up through, and now this trains the wire perfectly so that the line worker can start adding PBR blocks. Right here, this crew decided to use 2 3 shiv blocks, 1 out on the line about 10 feet. This is going to make dead ending a lot easier. We'll talk about that as we go forward. But right here is the example, is it comes through the 3 shiv block, and we're off and running with the PBRs. So now we've got the lead sled, the lead trolley running along the installed messenger. And now the PBR 3 blocks are going to be installed every 30 feet with a tag line that is going to run from the lead trolley back to the first PBR, and then every subsequent PBR block in the run. Now, how do you know how many PBR blocks you need? Essentially, you just need to know what is the entire length of the pole, divide that by 30 feet, and that's how many PBR blocks you're going to need. And again, these PBR blocks are tied together, so they run right along with the trolley at 30-foot intervals throughout the entire run of the line. And this is an example of a line worker having all of the PBR blocks up and ready, and you can see these are all placed on the messenger that has already been sagged, and the 3 conductors are running through the PBR blocks, and these 30-foot lines are hanging down so that as the one line gets tight, the PBR block leaves and continues on down the road to either the end of the pole, if it's a straight pole, or we'll talk about adding corners. But this is another example right here of the line workers installing PBR blocks with the 30-foot lines that run in between, and these are just going to go out on the line and support the entire support the wire for the entire run of the line. And you can see that PBR blocks will roll over the tangent brackets very easily. There's usually absolutely no issue. Gravity is your friend, and you can see the line that is tied to the block in front of it and a line that is tied to a block behind it, and that will support the line out for the entire run. Corners get a little problematic for the crews. As you can imagine, the trolley is not going to be able to go around any means of attachment to a corner pole on the messenger. So as a result of that, what the crews have to do is run the PBR blocks up to the corner, tie off the first the first PBR block, either to an eye nut or something, or even to the pole, and then baby the wire across this corner, placing the cables or the conductors into these corner blocks, and then start up the installation of the PBRs again from that point forward. So when using the roll-by method and coming across corners, there is going to be many times where the crews will have to start and stop the installation of the PBRs to get past these corners. And the way that you baby this through is by either using a material handler, possibly a digger, or even just using a come along out on the line, just to move the lead trolley past this corner, install the cables into the corner, and then continue your pull as you go forward. This is, again, an example that you can see the 3 phases coming through these blocks. Now they've installed the lead trolley on the other side, and from this point forward, you just continue to add PBR blocks to the rest of the run or to the next corner.
Excuse me, Carl, we did have one quick question. How does the PBR block keep you from jumping off the messenger?
Well, gravity is number one. Certainly, every now and then you will have a place where the stresses are such that it will want to jump off the messenger. If you're having that problem, probably a 3-shiv block out on the line would help train those cables. But honestly, gravity in most cases will keep that trolley and the PBR blocks down on the messenger. Hopefully that answered. And we'll move forward. So this is the roll-by method at the very end of the run. As you can see, the lead trolley is coming to the dead end. The P line has been placed into this single shiv block. And now you're getting to the point where you can actually dead end. And many times we'll dead end on a cross arm. We actually do make brackets where you can actually dead end on the bracket to keep the configuration. But many times you'll just dead end on a cross arm because you're marrying up to an open wire circuit. So right here is where you want to start getting, the line crews want to start getting ready to insulate and dead end the cables as they come to the dead end structure. So in review, the pole by pole, or I'm sorry, that is essentially the way that you run in the roll by method. Pole by pole method is significantly different, yet the result is the exact same. Pole by pole method is going to utilize 3 shiv blocks at every location that you're going to ultimately install a spacer. So as you can imagine, the upfront cost of using the pole by pole method might be a little bit higher due to the purchase of 3 shiv blocks rather than just using the PBR blocks to roll the wire out. So I have many clients that utilize this method. This is great for corners because you're not setting the rollers out onto the line. You're actually pre-placing the 3 shiv blocks at 30-foot intervals out through the line, and then running your P line through that block. It's a specialized sled that you use to traverse through the 3 shiv block. I'll have a picture of that in a moment. For heavy corners, as you can imagine, the pole by pole method is a little bit easier because you don't have to pull past anything to clear your blocks from any obstructions. The wire just simply pulls through, and once you get past the corner, you just push the conductor back into the corner blocks and continue your pull. And the concept is, again, to place a 3-shiv block at every location where a spacer will be ultimately. This is a sled that has been designed. As you can see, this is designed to run directly through a 3-shiv block without twisting. Not to say that it can't twist, but at 30-foot intervals, it doesn't really give the conductor a lot of time to twist. But, you know, as crews are watching the wire in, if it does twist, it means a setup and going up and untwisting the wire. But typically, this will stay flat and will install very easily through 3-shiv blocks. Again, this is a picture of the 3-shiv block with the sled coming up to it. This is going to go straight through the 3-shiv block, and the sled is designed to go through the rollers and then essentially place the conductors into these rollers for the extent of the pull. Dead ending is the exact same, regardless of what method you use. We strongly ask to use preformed dead ends similar to that of a guy wire. The concept of utilizing spacer cable is to reduce the ability to have any energized parts, and if you do, to protect them. It's not to say that you can't use a mechanical dead end, because you can. However, you cannot use a mechanical dead end on the covering. So if you're going to use a mechanical dead end to dead end your conductors, you have to strip that cable out prior to placing in the mechanical dead end. With the preformed dead end grips, there is no conductor stripping associated with installing these grips here. So sagging the cables, you certainly dead end the cable at the furthest spot from the payoff trailer. Using mechanical dead end clamps for the conductor must be stripped, as I already said, and the payoff trailer end of the pull can use braces to either sag the conductor with 3-shiv blocks. As you're sagging the conductors, this is, you know, kind of where line workers will want to maybe over tighten the conductors. It's very, very critical at this point. Once the conductors are in, the messenger is sagged to where it needs to be. All of the either the roll by blocks, the PBR blocks, or the 3-shiv blocks are where the spacers are going to be. You're going to get a real good understanding of what your sag should be. However, it's extremely important to again consider the temperature in Fahrenheit or Celsius for the day that you are installing. It's you know, a nice fall day in the Northeast, and it's between 50 and 60. You're going to have certain levels, and these are inches of sag for the temperature of the installation. As you can see, you will get a little bit of sag. You want to measure your sag at the 15-foot interval in between, which would be basically directly in between either the PBR blocks or the 3-shiv blocks, depending on the installation method used. We include a sag gauge, again, going out mid line, not necessarily at closer to one end or the other, and then halfway in between the blocks to get a real good view of where the conductors must be sagged at. Understand, it's good to note here that when once you install your spacers, sagging becomes very, very difficult. So you want to get your sag correct here, and sagging it too tight when it gets cold is going to have a real adverse effect on the line itself. So sagging the conductors to the messenger using the Hendrix sag gauge is a critical piece at this point. Again, not practical to sag conductors once the spacers are installed. However, once the spacers are installed, if you still have a little bit of issue with the sag, you can always add spacers. We suggest 30 feet, but if you want to correct some sagging issues after installation, adding spacers to take up any slack is certainly one means of correcting sagging issues. So completing the installation is now that your messenger is sagged, your conductors are all sagged. Now removing the PBR blocks and the P lines or the tag lines in between the PBR blocks or the 3 shiv blocks, you want to replace them with the actual spacers as we get closer and closer to the end of the installation. As you can see, these have been innovated throughout time and throughout history to accommodate a better means of connection. You can see this ratcheting type of connector that clamps down on the wire. This is hot stick accessible, so you can install and remove these spacers utilizing hot stick methods. But when it's first being installed, very easy for the line worker to clamp down on the messenger, clamp down on 3 phases, remove the block that is supporting it, and move on to the next. For the actual placing of a spacer at the pole, as you can imagine, with this bracket in the way, it would be impossible to attach right directly at the pole. However, we do include this stirrup that can be attached to the bottom of the bracket where the spacer can actually be installed right directly at the pole. And there's a really good reason why we want it at the pole, is so that we can eliminate or at least discourage the ability for this line to do any moving back and forth, regardless of whether it's from a tree falling on it, from a vehicle accident, or even just regular vibration. And that's by using this anti-sway bracket. Many companies use this even on for virtually every single pole. This stabilizes the bottom of the spacer to ensure that this spacer or that this system stays put and has little opportunity to move once installed. Again, for those that have never been in a chair or a messenger basket, this is a line worker being pulled out onto the messenger via this messenger chair. As you can see, these areas are not every area is accessible by a truck. This is going over some sort of a pond. The only means to replace the PBR blocks is to actually get to roll out on the line and replace the PBR block with a spacer all the way out to the next pole on the other side of the installation. And here is a picture of the line worker doing exactly that. So now our cable is installed. We're not going to get into stripping spacer cable, but stripping spacer cable can be a little bit of a task. We encourage 3 different tools, or we recognize 3 different tools, 2 from Ripley and 1 from Speed Systems. Certainly a webinar for the future is to talk about stripping spacer cable. It can be a little bit cumbersome, but at the same time is easily done. For those that don't rubber glove and just hot stick, Ripley actually makes a hut stick stripper that attaches right onto the line. It has different die sizes for different size conductors and can be utilized by using hot stick methods. As to splicing spacer cable, we include Burndy partial tension splices, essentially a barrel sleeve connector that is crimped down using a die type machine, whether it be an MD6 or, as you see here, a battery operated MD6, crimping the wire. There is there's very little tension on the conductors themselves as they are supported every 30 feet from the messenger. So a full tension splice is not necessary, but a partial tension splice by using crimps is the way that you would either extend or repair spacer cable. And we encourage anytime that you have to open the wire, again, the concept of having covered wire is to protect it from different potentials and exposed potentials. Using mastic tape with a cold shrink wrap maintains the integrity of the covered system. At every time, every moment that you want to open up the wire, either for a tap, for a transformer, for any reason at all, we encourage the use of line duct, which is protective covering. It stays in place by tying with aluminum tie wire directly onto the messenger, 2 feet each side of the open point. So right here is a hot line clamp. We want to center this line duct, this 4-foot piece of line duct right in the middle so that it protects 2 feet this way, 2 feet this way, to ensure that no other potential can come in contact with the opening. And again, this is an example of that. Finally and lastly, lightning arresters are critical to the long-term health of a spacer cable system. Anytime the wire is open, we would like to see arresters installed specific to the voltage class that the circuit is running at. For a transformer, as you all know, are supplied with arresters, so that is really not that big a deal there. But anytime there is a transition or tapping over a 3-phase or a cross arm, if there are open points, you want to protect them by using an arrestor. So again, dead end splices and grips, preformed is preferred. However, if you're going to use a mechanical dead end, please strip the wire to accommodate the mechanical dead end. And with that, I will turn it back to Kristen. Hopefully we'll have some questions that we can review as we roll forward.
Yes, thank you very much, Carl, for that excellent presentation. Before we jump into the Q&A segment, just a few reminders for everyone. Our final webinar in this series will be held on June 24th at 1 o'clock Central Time. The topic is restoration and safety. We'll discuss restoration procedures and necessary safety considerations to help you properly maintain your spacer cable system. Also, as a reminder, participants may request a certificate of completion to submit to your PE boards for CEU credit, and you can send those requests to myself at kvanderwall@marmonutility.com. Carl, if you could just advance to the next slide, please. Also, there will be a brief survey open in your browser at the conclusion of the webinar, and we would greatly appreciate your participation. If you have any further questions, once this webinar concludes, feel free to reach out to your local Hendrix representative or sales manager, or you can send an email directly to our Director of Sales, Dave Shockley, at dshockley@marmonutility.com. And now we will jump into our Q&A segment, as we did have a few questions that came up during the presentation. Carl, one question that was asked is, what are some of the common mistakes you see made by crews during installation?
Oh, wow, that's an excellent question. Over tightening the conductor sag is probably the most common. You know, I live in the Northeast, and a lot of my clients have varied climates in terms of the seasons. So when you know a line is constructed in July in the Northeast, and it might be 80, 90 degrees, the crews sag the conductors to one level. And then when it gets cold, of course, that is going to make those conductors significantly tighter than they were installed, and which ends up in, you know, bending insulators and things of that nature. That would probably be number one. Number two mistake would be not including line duct to protect the messenger at open points. Those are probably the number one and number two.
Thank you. We just had a question come in. Do you have any words of advice on double circuit installations on angle structures?
Double circuit installations. Certainly you want to keep your distances, because you know, with any installation, it's easy to install. It may be difficult to go back and work on after the fact. The kind of cool thing about spacer cable is once it's installed, you very rarely have to do anything to it other than maybe strip it for a connector. So for double circuits, you know, it's very easy to hang tangent circuits on each side of the pole as long as it's a straight line. When you get to corners, it becomes a little problematic, but you know, rather than having a single insulator at the pole, by putting double insulators per conductor, and we make brackets to accommodate them, that eases the angle a little bit, or significantly. So yeah, those are the things that I would strongly suggest, is that if the corner is over, say, 20 to 60 degrees, by adding two insulators at the pole rather than just one alleviates a lot of stress on that cable.
Thank you. And then another question is, does Hendrix offer on-site training?
Well, that's just a big softball for me. That is actually my job as part of our service package. Not only do we complete the design, but we actually do a pre-construction or a pre-design walk down, which both myself and Mark Baker, who is my peer, will do. So, and then we will either work with the contractor or work with the homegrown line crews or what have you, to do exactly that, is to train as we go on site. There's no better training than that type of training. You know, I can sit in front of a PowerPoint all day, but without being out and working directly with the crews and offering them advice through real live situations. Yes, we definitely offer that as part of our service package. And then we actually, Mark and I will do a post-construction audit just to ensure that the line was installed correctly, you know, with appropriate line duct, with appropriate connections and things of that nature.
Thank you. Another question was, if there is some vegetation entangled in the line, do you need to take an outage to clear it?
Well, again, a really great question, and you know, I can talk about my background and the company that I worked for, but my rules may be significantly different than yours. If a tree or vegetation is entangled in a wire, you have to treat this just like bare wire. So utilizing an insulated stick saw, you can usually get yourself out of trouble. But if you have to encroach on the minimum approach distances and get that closer, if the vegetation has grown up through that you just can't maintain those distances, then yeah, you'd probably have to take an outage. That's why, in the design phase, it's not always feasible, but we encourage our customers to build in intelligence into spacer cable systems via reclosers, loop schemes, things of that nature. So, so that you can minimize the impact to customers if possible. But every now and then, yeah, if you don't have a strong veg program, then yeah, trees can grow, and they can grow up through this pretty easily.
Thank you. Also, you said in your presentation that phase conductor sag is very important. Too much sag is better than too little sag. What are the drawbacks of pulling in the phase conductors too tight?
Exactly that. If you have a consistent climate, if you are in, let's say, Florida, where it's warm most of the time, you might not have too much issue. But anything in the north that has seasonal changes, where you can have temperature swings, in a year of maybe even over 100 degrees, that is going to affect the sag of the wire. The wire is going to contract in colder weather. So if it's too tight when it's put in July, in December or January, it's conceivable that you might have some issues. So using the sag gauge by the temperature guidance is pretty critical.
Thank you. And next, when setting up the reel trailers and feeding the phase conductors up to the messenger on the first pole, do you recommend any grounds be placed? And if so, what are your recommendations?
Certainly, if your local safety rules require you to ground the cable on installation, then you'd have to. You can't use a running ground on covered conductor. You'd have to use an arbor ground, which again just is a collar that fits on the arbor that is holding the reel of wire. The tail that sticks out of the bottom, basically the other end of the conductor, you'd have to strip off and make a connection to that tail, and then run that to your ground. If I were running in and around anything energized, I would definitely want that grounded during the evolution of running the wire. It's it's going to protect me. It's going to protect my peers on the ground. It's also going to protect equipment, and that you want to again defeat any reclosing when you can. If you're working beyond a fuse, just make sure that the fault duty is such that it will de-energize on an incidental contact. But yeah, I would definitely recommend grounding, but really the only way you can ground the conductor is by using an arbor ground on the arbor. So even for all three reels, you'd have to use 3 separate arbor grounds to the same either driven ground, or if you run a jumper up to the system neutral, or if your rules allow to use a pole ground depending on size of the pole ground, anything along those lines. But they should be interconnected in that way.
Thank you. The next question, do you have to mastic or seal tap locations? And when you abandon a tap location, should you mastic and seal the spacer cable where the tap used to be?
Great question. So we don't have a cover for, I'll take this in 2 pieces. We don't have a cover for connections today. So the way that we protect that is by offsetting. If it's a 3-phase transformer or a 3-phase device or a 3-phase tap, we try and offset the connection so that they're not in close proximity. And then we protect the messenger by use of line duct to ensure that you're just maintaining the integrity of the covered system. When you abandon an open spot, yes, I would strongly encourage some sort of a taping, some sort of a covering, grounding spacer cable can be a little bit of a chore, and having opportunities for abandoned, stripped out locations can be a real advantage. However, you're kind of defeating the purpose of the covered system if you just leave the wire bare. So yeah, I would encourage some sort of cover, definite mastic taping. You can't use a cold shrink if you're not opening the wire, but definitely taping for the abandoned bare spot, for sure.
Thank you. And then another customer asks, how can a customer go about obtaining the installation equipment?
That is that is a great question. We provide that, and I would have to defer to some of my sales peers to answer that more intelligently than I can. Not really my end of the business, and I'd hate to say something that isn't true.
Oh, no problem, Carl. I can help with this one. So when we help with the design, we can put together a bill of materials, which will also list the installation equipment that is needed. And what we offer is for one time, we offer for no charge that we will provide the installation equipment up to a 4,000 foot pulling span. So that is, again, we will offer the installation equipment at no charge for one project up to a 4,000 foot section.
Thanks, Kristen.
No problem. And another question is there a grip that can be used to sag with?
Yeah, certainly. The grip opening just has to be able to accommodate the wire size. So the grip gets pretty big. You can either use a spring-loaded grip or a what's called a bulldog grip, which is not spring-loaded and is kind of a tension type grip. Those tend to be a little lighter. The spring-loaded grips of that size are going to be kind of huge and difficult. You in a lot of cases you could tie a roll and hitch even with stable braid rope and be able to sag the conductors appropriately, because again, the conductors are supported every 30 feet. There's not a tremendous amount of pull on them. So just rolling them through the rollers for the sag, you're going to find that, depending upon how many angles there are on a straight tangent line of a mile, you'd be surprised at how close to sag you're going to be able to get just by supporting that wire every 30 feet.
And another question. Someone mentioned that they have seen pole-by-pole method done without pulleys every 30 feet. What's the recommendation?
Oh, yeah. The pole-by-pole method, yeah, I suggested in my presentation that that a 3-ship block be used every 30 feet. You could probably get away with maybe, rather than, let's say, 4 or 5 blocks per span, maybe 1 or 2 blocks per span. Sagging then becomes a little more challenging because you don't have that support every 30 feet. So yes, a pole-by-pole method can easily be done with fewer 3-ship blocks than there are going to be spacers. However, you just have to be aware that you have to ensure that once you do put the spacers in, that your sag is right. You may have to leave those spacers loose if you have to take a little bit out, which is doable. the wire will slide in those spacers a little bit, and not break or get out of line. So yes, the answer is yes. You can definitely do pole by pole with fewer than the block per spacer that I had suggested.
And is a mid-span tap installation possible for crossing conductors?
Mid-span tap possible for crossing. So I think what that is going toward is just being able to mid-span take a shoot off and go to another pole. That is not recommended. That would put undue stress to some level. I don't know how far you'd be going with the tap, but yeah, any side strain to the system would have multiple issues. So yeah, we really like to see taps come off poles. It's a good question though.
Okay, and it looks like
if I could add, Carl, this is Brian Traeger. I think what the questioner is asking about is what's called a flying tap, so that we have lines crisscrossing and we want to connect them. Yeah, there are ways to do that. We have drawings for that. We've got lots of photos. It's been done all over the place.
yes, Brian, they confirmed it was the flying tap they were referring to.
Okay,
Oh,
well
okay.
done.
I'm sorry.
And Carl, since you know a lot more about line work than I do, I will acquiesce to your recommendation. But yes, it has been done, and it has been done successfully.
Yeah, I think that it can be done successfully. I'm sorry that I misunderstood the question, but yeah, having flying taps with like a couple of circuits side by side, or you just have to train the wire correctly. You'd have to protect the messenger, certainly. But yeah, you could easily do something like that.
And Carl, how would you compare the installation time of bare versus spacer cable?
Wow, that's the $1 million question right there. I'm going to dance around this a little bit. For a standard line crew that has never really been exposed to spacer cable installation, spacer cable is probably going to take a little bit more time the first time, because as I said at the beginning, it's not difficult, but it is different. And once you've run one or two jobs, I would put running spacer cable ahead of running open wire. It's 2 pulls versus 4. Even though you have to stop and put in spacers every 30 feet, I've seen an awful lot of contractor resources as well as utility resources that were really good at this. Knock this out in maybe not half the time, but 3/4 of the time of open wire. It's pretty slick.
And looks like, Carl, we have one final question for today, unless any come in at the last moment. But do we offer final SAG and charts that are available to customers?
100% yes. Yes, we do. Certainly talk to your sales representative, but we have them on our website. We have them in all of our catalogs, and very easy to get a hold of the SAG recommendation.
All right, well, thank you again, Carl. That concludes today's webinar, as that was our final question. Thank you, everyone, for taking the time to join us. Again, a brief survey will appear in your browser once you leave the webinar, and we'd appreciate your participation. We hope you have a great rest of your day, and that we'll see you on future webinars. Thank you again, everyone, and take care.